Algebra 1 with Mrs. Carroll. So make sure you have that notebook that we talked about, and also pray before you start. So here is a warm-up. It's multiple choice. Tell me which one this is. It's you have the 5 and then you have the x minus 3 in the middle. Pause the video. Your answer is B. It's 3 from a number times 5. So make sure you have this first, and then it's also times 5 would be, so that way the parentheses is implied. Alrighty, so what we're going to be doing today is we're going to be doing Unit 1, Lesson 5. So we're going to determine some key operation words, interpret algebraic expression, and create verbal expressions. So now we're going to go backwards. Practice and create expressions. Interpret parts of an expression, such as terms, factors, coefficients, in terms of context. Write a number in scientific notation and interpret a number written in scientific notation. Okay, so our God moment is, I looked and saw a windstorm coming out of the north, an immense cloud with flashing lightning and surrounded by a brilliant light. The center of the fire looked like glowing metal, and in the fire was what looked like 4 living creatures. In appearance, their form was human, but each of them had 4 faces and 4 wings. This is Ezekiel in 1:4-6. And we have talked about how God does word problems. And in this case, God showed Ezekiel his the heavens, and Ezekiel had to write it in words. So it was opposite of what we normally have from God. So when given an expression, you need to be able to write it out in words. God gave us instructions in his Bible, and it had to be turned into expressions or equations. Ezekiel was given a vision from God, and while he and the Israelites were in exile in Babylon, he saw the throne of God and all the incomprehensible creatures that were in heaven. He had to put the vision into words. Okay, and today we're going to be doing a couple of vocabulary words, scientific notation. Hopefully you've heard of that. It's a simpler way of writing larger and smaller numbers. Verbal expression is a statement that is expressed in words. Okay, we're going to review really quick. Remember some of our operations. You have increase, plus, and then. For minus, you have less than, subtract, from, and decrease. You have all of these. You have product times, twice, double, and divided by, quotient, and quantity of, okay? So what do these words mean? All right, so what I want you to do is I want you to pause the video, and I want you to put an A, S, an M, or a D, or even a P for parentheses next to each one of these words, without looking at that sheet that is on page 99 or in 35 in your book, in your workbook, and see if you can name them all and get them right. So pause the video. Alright, there's the answers. I did write it all out so that way we didn't have any confusion, but you writing an M, S, A, or D, or P is fine. Okay, this one here, I want to go backwards. Cube root might have thrown you a little bit. It basically looks like this, okay, and a square root may not be something that you've seen before. Hopefully we talked about it in our first lesson, but you may not know what a cube root is. Don't freak out. It's okay. We'll talk about that way in the future. I just wanted to see if you knew. Okay, so review a little vocabulary. Please tell me in your own words what a constant, a variable, a coefficient, expression, and then show me an example. Pause the video. Alright, and those are the words. Hopefully you had them all. If for some reason you missed one or something like that, please go and review that lesson. Alrighty, so translating words into math. On the board, write some keywords known for addition, subtraction, multiplication, and division. So again, I want you to write these out on your page and make sure you're getting especially words like product and of, so that way you kind of get an idea of what they mean. Okay, pause the video. So since we're talking about algebraic expressions, and we're going to be doing actually verbal expressions for them. So you're given something like, say, x plus 3. There's a lot of different ways we could write in a verbal expression what x plus 3 is. Well, obviously I could write a number in 3, right, or n plus 3. Add 3 to a number plus 3, the sum of a number and 3 more than a number increased by 3. There is so many different ways we could write this. So today what we're going to be doing is you're going to do it backwards. So now we're going to be given an expression, an algebraic expression, and you have to turn that into words. So take a look at the next one. Subtract, so we have x minus 12. Subtract 12 from a number. Remember, from is a turnaround word. A number minus 12. The difference of a number and 12. 12 less than a number. Remember, that's also a turnaround word. A number decreased by 12, take away 12 from a number and 12 from a number. So be careful on those. Remember, from does turn it around. Okay? Another thing we can look at is 2m or 2 times m. You have 2 times a number, 2 multiplied by a number, the product of 2 and a number. You could have put double m or twice m. Those two also would work for 2. Okay, and when we have a division, so we have this a divided by 6 or a over 6. Those are 2 words we could use. 6 divided by a number divided by 6. What's wrong with these two right here? Oh, I'm sorry, into. So make sure you realize I said it wrong. All right, 6 divided into a number is good, and a number divided by 6 is good, okay? So don't get those mixed up on homework, okay? The quotient of a number and 6, that's another way of saying it. Okay, so there's plenty of different ways that you can say an expression. And you're going to be asked and given expressions, and you're going to be asked to name 2 or 3 different ways of answering them, okay? So let's take a look and let's do some practice problems, all right? We have A, B, C, and D on the board. I want you to pause the video and see if you can name a couple. I want you to try and name 2 or 3 for each of them. So pause the video. Alrighty, I just wrote 1, so I kind of cheated a little bit. Sorry about that. A number divided by 4, but I could have said the quotient of n and 4. And on B, it's w plus 5, so a number increased by 5, a number added to 5, a number plus 5. C, I could have had that n minus 10, 10 less than a number decreased by 10, a number minus 10, those are my 3. And then D, I have R times 20 or 20 times R. So I have 20 times a number multiplied by 20. I could have had a number times 20, that also works, because you can have either order for times. But the coefficient, the number always goes in front of the variable. All right, let's try that again. So pause the video, see if you can come up with some different ways of doing this. All right. Okay, I have the product of 5 and a number 3. So for E, I have that one. For F, I have a number decreased by 8 multiplied by 4. So you see that kind of goes along with it. And then I have 3 times a number decreased by 5. I have 2 times a number minus 1 divided by 4. I could have had the quantity of 2 times a number minus 1 divided by 4. Does that make sense? So you could have a little bit of extras there. But a lot of times for these harder ones, 1 answer or 2 would be fine. They can get a little harder, and plus they can get a little more confusing. Okay, let's try this one more time and see how well you do. Pause the video. I have 3 times the number minus 7. You could have had 3 times the number decreased by 7. For L here, the quotient of 4 and a number increased by 10. So I wanted to make sure that quotient means I do have a numerator and a denominator. The quantity of a number minus 2 times 6. And then I have 5 divided by the quantity of a number minus 3. So that's just 5 divided by x minus 3. Okay, hopefully you got those and they weren't too difficult for you. Okay, I just want you to say which of the following is a verbal expression that expresses this particular expression. You have A, B, C, or D. Pause the video and see if you can figure it out. All right, the answer for that is 15 less than a number. Hopefully you got that. Alrighty, so here's an activity. I want you to match up these expressions with the algebraic expression and pause the video. Alright, there's your answers. Hopefully you got them. They'll tell you which one they go with. And as I said, I did move them around a little bit. Okay. So let's talk about scientific notation a little bit, where God takes big problems and turns them into manageable ones. Alright, so scientific notation is a way that scientists take big numbers or very small numbers and create easier ways to read them. They're smaller to read. Your calculator is a good example of writing it in scientific notation. If you have a calculator and you put a big enough number in there and multiply it by, I don't know, a bigger number, you'll notice that it has either an E or it has some sort of symbol, and then it has a number after it. Some of your larger ones, your TI-84, has the letter E after it, which means it's 10 times whatever that number is after it. So scientific notation starts with numbers 1 through 9, right? It doesn't go any higher than 9 and it doesn't go any lower than 1. It has, so it can go 9.11, 9.99, but it can't get up to 10, okay? It has a 10 to some power afterwards to get rid of the rest of the numbers. For example, if I have something like 9,285, I would move my decimal point over 3 spots, and I would make it 9.285, and those decimal points that I just moved over, I would put in the times 10 to the third power. So if you kind of think about it, it makes sense. I have my decimal here. I move it 1, 2, 3 places to between the 9 and the 2, and that's where that 3 comes from, is how many times I moved that decimal place, okay? Alrighty, so let's take a look. I want you to pause the video. I want you to try this out and see how well you do. Pause the video. Alrighty, so here I have my decimal point. I'm going to move it 1, 2, 3, 4 places. It needs to be between the 9 and the 4. So I have 9.4 times 10 to the 4th. You notice I did drop the zeros. Make sure you realize that you don't need them unless it is an actual number. So what about a small number? And I want to get it where it's a little bit more manageable. And so it still needs to be between 1 and 9. So example would be, we would have this 0.000358, and I want to make it bigger so I can kind of see it a little bit better. So I'm going to go 1, 2, 3, 4. But you notice that I went to the right 4. So that means I went -4 instead of +4. So if we kind of look at the previous one here, this is a good example. I'm making this smaller. So this is a large number and it's going smaller, okay? And what that does, okay, so a large number going smaller, okay, makes this get bigger, okay, so this becomes bigger, okay. On the other hand, if I have a small number and it's getting to be larger, then this is going to be smaller, so it kind of goes along with the small, all right. So in this case, I start with a decimal between 1 1 and 9, so I noticed that the number would have to be 3.5. Okay, that is between 1 and 9. And then, as I said, I just count. So I'm just doing 1, 2, 3, and then in order for me to get there, I have to move -4 direction, okay? So write that in scientific notation, pause the video. Okay, again, I would be talking about 1, 2, 3, 4. I'm getting a number between 9.4 is good. So my whole numbers are between 1 and 9. 10 being the top number I could get to, but I can't get there. And here I have a -4. So notice I didn't write the zeros in front either. So let's do some practice. I want you to do 1 through 8 here. Pause the video and see how well you do. Alright, there are my answers. You'll notice that this is a negative, that's a positive, positive, positive. This one may have confused you just a little bit. You do have to move it over 1, hence why it's a 1. This one here is positive, that's negative, negative, and then also negative. So hopefully you got all of those and it wasn't too bad. Let's try out one more. Okay, now we're going to turn it into standard notation. So pause the video and see if you can do that. Alright, here's my standard. This is positive, so it's going to be bigger, positive bigger, negative smaller, positive bigger, smaller smaller because they're negative. This is positive, so it'll be bigger, but you notice it only went over 2 times, so that might have confused you a little bit. I still have a decimal in it. And then this was smaller. Okay, so let's do a mixed review. It may just see how well you do on these. Pause the video. Alright, there's my answer. Hopefully you got all of those. Again, I only had to move it over once, so hopefully you remembered from the last time that you only did it once, so therefore it's only 10 to the first power. You don't have to write the first power here. I could have just written 10. It's just to make sure you understand where it is, okay? Alrighty, so here's one more practice for you. I wanted to see how well you do. Pause the video. Alright, there you go. And hopefully you got all of those as well. Okay, so your homework is Unit 1, Assignment 5. It is 36 in your textbook and 5 in your workbook. Alright, exit ticket. Which phrase is not this expression? Okay, pause the video and see if you can find the one that's not correct. Alright, the answer is C. The difference of 2 and a number would put the parentheses here, plus 3. So that would be the reason. You have a great day, and I'll see you next time.